The team at Intuit Israel, led by Shir Lador, has hosted Words Tel Aviv for the last 3 years. Shir is also moderating a panel today at Words Worldwide on data ethics and responsible AI. So it only fits that during Words Tel Aviv 2020, Hila Gonin, now a postdoc focusing on natural language processing, delivered this talk about gender bias in word embeddings.
Hi. So let me start with a quick question. A doctor is walking down the street with a boy. The boy is the doctor's son, but the doctor is not the boy's father. How is that possible? Yeah. So the doctor is the boy's mother, and this is something not everyone can answer at the first few minutes after hearing this question, and the reason for that is that we're all biased. My name is Hila Gonin, and I'm going to talk about a joint work with Yoav Goldberg from Bar Ilan University about gender bias in word embeddings. First of all, I will give you some background about gender bias in modeling in general. Then we'll talk some more about word embeddings. We will review some current debiasing methods. And then we will analyze the biased embedding that we got from them. So first of all, what do you mean by gender bias? We can see gender bias in many applications nowadays, one of which is translation. You can see here that the doctor is standing over there is translated into Hebrew as Harofe Omed Sham, while the nurse is standing over there is translated into Hebrew as Ha'achot Omedet Sham. And Harofe is the male form of doctor, and Ha'achot is the female form of nurse. Another translation bias is this one. The smart teacher is translated into French as le professeur intelligent, and the beautiful teacher is translated as la belle prof. And you can see by the article that the first translation is of male and that the second one is of female. Gender bias is also occurring in other tasks. Consider this example of a co-reference task in which you are asked to group different instances of the same entity. So in the first sentence, the physician hired the secretary because he was overwhelmed with clients. We know that the true answer is that he is actually the physician, and this is what the model says. But in the second sentence, we know that the true answer is that she is the physician, when most models would say that she is the secretary. And the same goes for the third and the fourth sentences. There the right answer is that the pronoun is the secretary, but when the pronoun is he, the models tend to relate it to the physician. And another and last example, image captioning. Given an image of a person, you are asked to generate a caption that describes the image, and you can see on the left that we have an image of a woman in front of a laptop, and the baseline generates a sentence, a man sitting in front of a laptop. And you can see that the red area that describes what the model focused on is focused on the laptop instead of the person that we're interested in. In the second example, the model did the right decision, but again, not for the right reasons. It focused on the racket instead of the person holding it. So all these biases are something we really want to avoid, and we're going to focus today on biases in word embeddings. So first I'll say a few words about word embeddings so that you will be more familiar with it. Word embeddings are a way to represent words with the aim that two words that are similar will get similar vectors. We usually use a dense representation and each word is represented with a vector of roughly 300 dimensions, and all of them are embedded in the same space. And they are widely used in many NLP natural language processing tasks and applications. One important thing to note about word embeddings, that Diane already mentioned, that they are learned from raw data. And this is because of the distributional hypothesis. We expect words that occur in same context to be similar to each other. Here is an example of a visualization of a word embedding. Yeah, I guess you can't really see that, but we can see that band, album, and song are grouped together. We have product and product, development and growth. Words that are similar in meaning appear next to each other in the visualization as well. This is another example. We have here a month of the year. We have different years, days of the month, all grouped together. Let's take a look at some more examples. Top K list of some words. So if you take the word dog, you get this list. We have dogs, bonzo, hound, terrier, all of these words that relate to dog. For food, we have words that all relate to food, nutrition, foods, meat, and so on. And here is the list of the word nurse. And I guess you can already detect that we have many words here that are inherently feminine, even though nurse is actually a neutral word. We have midwives and midwife and mother, all of which are feminine words. So here we already see a bias in the gender in the word embeddings. Okay, so let's dive into the definition of bias in word embeddings. We will take a look at a paper called Semantics Derived Automatically from Language Corpora Contain Human-like Biases. What they did in this work is they replicated known biases from the literature, not only gender biases, but many other types of biases. Some of them were neutral, like biases we have towards pleasant things like flowers and unpleasant things like insects. Some of them are problematic biases like race and gender, and some of them simply reflect the statistics we have in reality. And they also introduce some methods to identify these biases. So let's take a look at a couple of examples from this paper. Here we have a plot of professions where x-axis stands for the percentage of female workers in this occupation, and y-axis is the similarity to the association of the word embedding of that profession to female. And we see a clear correlation between the two. Here are some examples from another experiment they did. They took two groups of concepts, concept 1 and concept 2, and two groups of attributes, attributes 1 and attributes 2, and they show that concepts 1 and attributes 1 correlate very strongly, and also the same goes for concepts 2 and attributes 2. So they took examples like flowers and insects versus pleasantness and unpleasantness. They showed also a bias towards names, European American names and African American names, and the way they relate to pleasant words and unpleasant words. And also some gender bias, male attributes and female attributes against math words and art words. Now we want to define gender bias in word embeddings more explicitly. This was done in this work. Men is to computer programmer as woman is to homemaker. What they do is they actually check how similar a word is to he and she. So we don't really care about the actual similarity to he and she, we care about the difference between them, right? Because some word can be similar to both he and she, but if a word is more similar to he, then we say it's male bias. So actually we are looking at the projection of the word on the gender direction. We will just consider the gender direction as he minus she, but this can be more sophisticated. So here the bias of the word W is its similarity to the word he minus the similarity to the word she. Just the projection on the gender direction. And if the bias is positive, we say that the word is male biased, and if it's negative, we say it's female biased. Here are some examples of specific words. The bias of the word consultant is relatively close to 0. The bias of the word nurse, not surprisingly, is female biased, minus 0.2. The bias of captain is male biased, 0.15. And the bias of table, as you would expect, is also quite neutral. Here we have a plot for another paper that investigated the bias in word embeddings. We will talk about it in a few moments. Here you can see a plot on the gender bias on the gender direction, and we see on the right professions that are more stereotypically male, and on the left professions that are more stereotypically female. So we know that there is bias in word embeddings. We saw it in many cases and in many ways, and now we want to reduce the bias. We are going to look at two works that did that. The first one suggests to remove the bias after training. So you have word embeddings, and you want to remove the bias as a post-processing step. What they did is that they defined the gender direction, as we saw. They defined a group of inherently neutral words, which are the words that they were trying to debias. For example, nurse, we want to debias this word, but we don't really want to debias mother because it is female, and it's okay that this word has a female bias. So what they do is just explicitly zero the projection of these neutral words on the gender direction. So if you have the word W, you take its projection on the gender direction, WB, and then you normalize it. And now by definition, the bias of all the neutral words is 0. We will add this method later as Hardy biased. Another way to debias embeddings was proposed in this paper, learning gender neutral word embeddings. They took another method, and instead of doing a post-processing step, they did something during training. They use a well-known technique to train word embeddings, GLAV, and they just alter the loss in a way that concentrates most of the gender information in the last coordinate. And the idea is that when you want to use a debiased version of the embeddings, you can just ignore the last coordinate from all the vectors. The way they did that is they took two seed groups of male and female words, and during training they encouraged them to be different in their last coordinate. And in addition, similarly to the first work we saw, they encouraged the vector representation of neutral words to be orthogonal to the gender direction. Again, this encourages the behavior of having a zero projection on the gender direction. We will address these embeddings as G and GLAV. Okay, so we saw a work that does a post-processing step in order to remove the bias using zeroing the projection of the vectors on the gender direction. As we said, here the bias is 0 by definition, and they also show that they managed to generate analogies that are more true and less stereotypical. And the second work that altered the loss during training, they show that they decrease bias in co-reference resolution, the task we saw in the examples in the beginning with the physician and the secretary. So that's really good. We know there is bias in word embeddings, and now we know how to remove it. But is that really the case? Well, not that much. We're now going to look at 5 experiments we did using these word embeddings that we talked about. The first one, the Hardy biased embeddings of the post-processing step, and the second one, the GN glove of changing the training, and we'll see how they behave with words that are male and female stereotyped. So the first experiment is clustering male and female biased words. We take the most biased words from the embeddings according to the original bias, 500 male biased words and 500 female biased words. We cluster them into 2 clusters using k-means, and we get really surprising results. We get that in the first case, in the Hardy biased embeddings, we get an accuracy of 92.5%. And in the second case, we get an accuracy of 85.6, which is very high to embeddings that are supposed to be debiased. This is compared to almost 100 accuracy percent in both cases when using the undebiased version of the embedding. Here you can take a look at the plots of the clustering. This is in the case of the first set of embeddings. And you can see that there is not much difference between the original and the debiased embeddings. We can see also on the right of the debiased embeddings are kind of clustered into 2 distinct clusters. And the same goes for the second embedding set. Again, we can see that we have 2 clusters that are relatively distinct. This led us to think that there is something still there in the neighbors of the word, because words still tend to group together according to the bias they have. So we defined a new notion of bias. Instead of using the projection over the gender direction, we use the neighbors of the word to determine its bias. So we take the percentage out of 100 neighbors of the word, we take the percentage of male biased words and female biased words around it, and we look at it as a new way to define bias. And when we try to correlate this new definition of bias with the old definition of bias, we got really, really high Pearson correlations. You can see that in the first case, we got 0.68 compared to 0.7 before debiasing. And in the second one, 0.73 compared to 0.77 before debiasing. So again, there is something still there that we can easily compute that correlates really, really good with the like old definition of bias. Then we take a list of professions and we try to see how professions correlate, how the correlation between the new bias and the old bias looks for professions. So this is the plot of the original embeddings versus the debiased embeddings for the first set of embeddings. As you can see, it looks like I took the same plot. I didn't. So you can see what we see here is the x-axis is the old definition of the bias. This is the bias of the words before the biasing. And the y-axis is the bias using the new definition of bias of neighbors. So the percentage of male biased and female biased words out of 100 neighbors of a word. And you can see that the correlation is really good and really similar to the correlation before the biasing. And also you can look at specific words and see that here in the male area we have skipper and warrior, while here in the female area we have nanny and librarian, all match the stereotypes we have. The same goes for the second set of embeddings. We see the same phenomenon and relatively similar words both in the male area and in the female area. Okay, another experiment, the fourth one, association with stereotyped words. Here we replicated the experiments we saw in one of the previous papers I talked about with the groups, and we tried to see the association between the groups of female names and male names to groups of words that are male and female stereotypes. For example, family versus career, home, parents and children, we expect them to be more associated with female names, while executive management and professional, we expect them to be more associative with male names. And the same for the other two examples, arts versus math and arts versus science. And all these attribute words are exactly taken exactly from the original paper. And indeed, we see in all cases that the correlations are in the way we expect with very, very, very small p-values. So it looks like the bias is not there anymore, but actually it's there and not that hard to recover. And the last experiment we show is classification of gender. So we ask the question, can a classifier learn to generalize from some gendered words to other words? What we did in this experiment is we took the 5,000 most biased words. We took a random sample of 1,000 out of them, 500 male biased words and 500 female biased words, and we trained a simple SVM. And then we took the left 4,000 words and we evaluated on them. And what we got was pretty amazing. In green, we see the original embeddings, the accuracies with the original embeddings. And in purple, we see the accuracies with the debiased embeddings. And as you can see, there is not much change. Before debiasing, we got accuracies of 98%. And after debiasing, we can predict the gender solely by the representation of the word itself without considering its neighbors by 88 and 96%. So let's conclude. As we saw, word embeddings exhibit gender bias in many ways. Debiasing is very hard. When we try to debias embeddings, it may look like we're doing something good, and it may look like that on some tasks we get better results, but actually social gender bias is picked up by the models, and bias information is still there, even when by some metrics it looks like it's even really zero. And the main take-home message is that the way we define bias is very important, and we need to also think about our definition when we try to solve the problem. If you have any questions, I'll be happy to answer.
Hi, I'd like to ask, the bias is actually in the sampling, and bias in sampling is something that is very common, not only regarding to gender, but even in words that are not such socially problematic, but even when you sample data from patients and you sample only the sick and not the healthy. So are there ways to do the debiasing in the sampling part or in weighting the input data?
I think that the solution, if there is such, should be in doing something with the data. I mean, the bias is really in the data. The reason we have bias in so many models is that the data is biased. It's true, and it has been shown that the bias is not only because of the data itself, but models do tend to amplify biases in data. But if you have unbiased data and perfectly equal distribution of everything, you won't have bias in your data. And I believe that the solution relies there. I can't really tell you that I can find data that is unbiased, but if our reality will be less biased, then the models will be less biased as well.
Maybe you can use your models to debias the data.
Yeah, hi, I just wanted to remark that you can probably generalize from what you showed to the way we're constantly unsuccessfully trying to debias our own minds, thinking that we are debiasing them. But just a short question, you showed earlier a plot that shows the correlation between the prevalence of women in different professions and the way they are perceived. And we were all very curious here about the clear outlier on the right end.
The what?
There was a clear outlier, and we were curious as to what it was.
Just a second. Yes.
Yeah, what was that? The orange one?
Which professions you mean?
Yeah.
I
One
guess
that has 100% women but still manages to be unbiased.
this you know, it's data. Not everything is perfect.
Well, I'm going to check that.
Hi, thank you for the great talk. I just wanted to ask, to your best knowledge, do you think there are currently no algorithms for debiasing, not only on gender parts?
Okay,
but
so we need to separate word embeddings and other algorithms and tasks. And yes, this is something that people are working on constantly. I don't know a good debiasing method for word embeddings currently, but as I said, people are working on it. And it is dealt with other things as well. I don't know if you know that, but for example, Google Translate started in production using two options for translation when it's applicable, only in Turkish. But still, when you have a sentence that can be translated both to female and male, you get both translations. And I think it's a really cool way to solve this bias, because people can say that you want your model to reflect the reality and the data, and you want to be able to say that doctor is usually male, because then you will be right. I don't completely agree, but a really good solution is to give the user the option to choose and let him be aware of the options.
I was wondering, the reason we have all these biases in data is because the corpora has these biases built in because our language, our culture has them built in. So is there any way that just artificially to change the data just to sample the words that we're worried that they're gender biased and somehow just randomly flip them, in the sentences that we have in our data?
So I think it's not that easy, but yeah, it's a good direction in my opinion.
I wanted to ask about a similar direction. Isn't it possible to just take all the he, she, all the nouns that say what is the gender and just make it one? So we will.
Yeah, I tried that.
Okay.
Didn't work.
Why not?
Because the pronouns are not the only indication. Mm-hmm. Even if you remove pronouns, you can still find yourself with data that uses the word nurse more often with woman and secretary and so on, and the same for stereotypically male words. So I did try that, and no, it doesn't work, but I do think this is the way to go.
Okay, cool. Sorry. Continuing on that line of thought, maybe we can use some other language like Hebrew, for example, that have different, and then resample to make.
So yeah, that's a really good idea. It's much more, in my opinion, it's much harder in morphologically rich languages that have gender in them, and actually we don't even know how to define the bias there, because if we have both forms of doctor, so yes, I want רופא, the male form, to be male biased, and רופאה, the female form, to be female biased, because this is what they are. So we really first need to define bias in these languages before we try to debias embeddings in other languages. But this is also work that is being done by people these days.